All right, welcome to episode 2 of Programming the Apple IIe using assembly language in the modern era, where we're using the Apple Win Apple IIe emulator to do it. So working through assembly lines, the book. Let's get started. So in this episode, we're going to talk about the book. So let's get the book first off. If you go to ct6502.org, that's Chris Torrance's website for assembly lines, you'll see here the book is listed. Click on the book. It'll click on all those. Click on the book again, and it'll allow you to buy it. I highly recommend buying it. I own it. It's a great book. Um, but you can also download the PDF version. So download it and open it in your PDF reader, and you'll see something that looks like this. Nice cover, a couple of title pages, and copyright information. The original cover looks something like this. And then we get into what the actual book contains. What it contains is a preface by the editor, an introduction by the author, then 32 articles, maybe 33, yeah, 33-ish. And then several appendices that are useful, including the Beginner's Guide to Merlin, which is really helpful if you're new to Merlin. And I was totally new to all of it, so it was good to me. So let's see what else the book's got. So preference goes on for a bit. Then we get into what's called Volume 1, which was the original assembly lines, 16 articles, has the original introduction, and then it gets into chapter 1, Apple's architecture, which we'll come back to in a minute. But if we go on down, wow, I don't know about scrolling through the whole book, but let's just see if we can get lucky somewhere around 16. Yeah, you got lucky. There it is. There's a second volume, starts at 16. So there you have it. That's the orientation to the book itself. There's you're in the right version if you got this picture on the back cover. And let me tell you, here's John Romero's comment here on the book. John Romero, probably the smartest man I ever met, for sure. Very, very smart. Did all of the original id stuff, him and American McGee and some others. But anyhow, that was a complete aside. So let's scroll into chapter 1. So the first thing that the author kicks off with here is a just a discussion about the Apple. And normally I'd be tempted to skip it and just get on with the programming, but it's kind of interesting. So you see this picture of the Apple. This thing is about 2 times as big as a pretty big laptop, like a 16-inch laptop, twice as long. It's about 5 inches tall, so it's pretty small for PC standards, but it's pretty big compared to your laptop. But what we have here is when you take the cover off. Okay, this is the keyboard. You take the cover off, and this is what you see inside. This over here is all power supply, and then you have 7 little slots, and then you have this thing. I guess A is probably the 6502, and then yeah, it is. I'm looking down below, and then these are the banks of memory. So basically, this is your processor. This is the memory. These are your slots for peripherals and extras. There's another slot on here. I'll see where it is, but it's called aux slot, the auxiliary slot. Somewhere it's around, but anyhow, you'd see that as well. But all these other chips that are in here are really just support chips, and that's what he tells you here in the reading. How does it work? Well, it pulls stuff out of memory and runs it. Interestingly, when this was happening, people would be running their computer and they'd be presented with a line that looks something like this when something went horribly off the rails, like beep, and then 8B F2 dash A, which was to anybody who didn't know, this is complete nonsense. But to us, what it's going to mean is this is the memory address 2 bytes after it broke, okay, just because of the way it works. And then it has the accumulator value that was in the accumulator at the time it crashed, what was in the X register, what was in the Y register, what the process status flags were. I don't remember S, maybe status or something. If you look somewhere, yeah, somewhere it says something about it. But anyhow, and then it gives you a map of memory from the low memory, the first 16K, the second 16K, the third, and so on and so forth. And then he tells you that this top 16K from 49,151 up to 65,535 or BFF to FFF, that's all reserved for ROM mapping in its contents into your memory. So this is effectively, this is the RAM that you had, 48K RAM, and then 16K was reserved for the RAM. Then he goes on to talk a little bit about hex notation. Basically, you have in decimal, you have the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, the 10 digits. And then for hex, we need 16. So they went and used A, B, C, D, E, and F. A being 10, B being 11, C 12, D 13, E 14, and F 15. And then things like this 10 would really mean 16 because it's 1 times 16 to the 1. Anyhow, you can read about it. All good stuff. And then you get into the kind of a exploded view of memory. Here's one memory location up to 16 bytes, and then it shows you that compressed in and so on and so forth. Again, read up on it. Yay, exciting stuff. Talks about the registers and having access to the different registers. Here's kind of another view of the architecture. The 6502 itself has an accumulator where we can store values and retrieve values. And when we do math, like adding numbers and stuff, they go into the accumulator. Then we have the X register and the Y register. Those are three of the kind of locations inside of the CPU, which means they're super, super, super fast. We can access those directly. It gives us a window into that. And then there's kind of memory, which is much slower. Then we have access to that 64K. So we can move stuff from the CPU out to memory or from the memory back into the CPU. And then it goes on to relate some story that I'm not sure is true, but it sounds like some tribe had dogs and the dogs had 4 legs, and that's how they learned to count. I'm thinking it's just a story, but that was it for the chapter 1. Really, just an intro to hex math and a little bit of how the 6502 and how the Apple IIe works with the CPU and memory. The second chapter is about the monitor, and I covered this kind of in the first video, but gives you some details here. It tells you to enter the monitor, you call from basic, call 151, you get an asterisk as a prompt, and now you can say, show me some addresses, and it'll show you some addresses, their values. Then it tells us that we can also disassemble the same address. And if we do, it displays that information. Good stuff. And it goes on for a bit. And then we get into chapter 3, which is kind of where we're going to start. And that's sort of the meat of it, as far as I'm concerned, is how does this work? And I covered this also in the first video, but it deserves some repeat. So we'll take a look at what it says. It explains kind of the process of entering the monitor and the mini assembler. And I'll cover it again in a minute. But basically, when we boot up, we can, from integer basic, and just like it says, from integer basic, we can enter the monitor with call -151. And then we'll be presented with an asterisk prompt, at which time we can call into or run the mini assembler from location F666 and jump into it. And when we do it, we get an exclamation point as a prompt. And we can do things like type our program in assembly, which is crazy. And it will, once we do and hit return, it'll assemble it. And then we can put a space and RTS, and it'll do the next line of the assembly. And you can then exit. It gives FF69 as the address, but when I read the ROMs, when I read the owner's manual stuff, it says FF69. So either one works. So yay, do that. Then we have the ability to list our program, 300L. And this is from inside of the monitor. We're back at the asterisk prompt. And then it'll show our bytes that we changed and some probably others. And then if we want to run it from the monitor, we can just type the address and go. Or if we want to exit back to basic, it says Control B, but in our little world, it's Control F2. Then you can call 768 and it beeps. And we'll run through all that right now. So that's kind of what the book says. Let's test the theory. I'm going to get DOS. Yep, DOS. And we'll leave that alone and we'll boot. So we're nowhere in DOS. DOS gives us the ability to get into integer basic. So there, we're in integer basic. We call minus 151. Now we're in the machine monitor and we can tell that there's nothing really going on at 300L. So let's enter the mini assembler. So we type in the address, which is F666, and go to go. There we are. We get the exclamation point, which means we're in the mini assembler. We type the address where we want to assemble code. We put a colon and a space, and then we can start typing code. And the code I'm going to type is the same stuff I typed last time. Jump subroutine, JSR, and then FBDD is our address. We hit return. It gets compiled or assembled into this right here, which is bytecode 20. And then DDFP, remember that this is a little Indian machine, and so DD is the least significant byte of the address, and then followed by the most significant byte, which is FB. And we'll look at this in memory because then it'll probably make a little more sense. But right now, this is good enough. It did the right thing. We don't want to have to figure out what address comes next, even though it's 303, because 20 is 300, DD is 301, FB is 302, and this would be 303. I could type 303 colon and then space and then type it all in, but they give me a shorthand in the mini assembler. If I just type space, it figures out what the next address is, and I don't have to worry about it. And then I can just type my code, my assembly language mnemonic, which is return from subroutine. We hit enter. It gets assembled at location 303 like we expected, and the bytecode is 60 for that command. And we're done effectively. All right, we could do more here, but it's just as easy just to go back to the monitor where it's easier to do things. So to go back to the monitor, we have to type dollar so that it knows it's hex. And then we type F, and then F, and then we could type F, 59 like it said, but I'm going 69 because that's what I read. So I'm going with that. And oh, well, that just shows me what's there. FF69, and then G for go, and there we are back in the monitor. Okay, so at this point, we can look at the codes we've changed. We've changed 300, 301, 302, and 303. So I can put a dot 303 and see all the bytes I've changed. 20 DD, FB, 60, or I can just kind of list from 300 to like 320. That's plenty. Whoops, 300.320. Okay, and you can see that it's zeros everywhere else. So yeah, it's there. Our code is there. Let's look at it byte by byte just so we can convince ourselves that we're looking at what we think we are. So there's the low byte in memory. It starts at 300. It's at 20. What's the next one? 301. What does it contain? DD. That's the least significant byte. It's a little Indian system. This is the lower side of memory. It gets the least significant byte. Then I type 302, and it's the most significant byte. It's higher in memory. The other one's in 301, this one's in 302. And then 303 is our return, and yay. We can also disassemble it, 300L, and it shows us on the left kind of the bytes as they appear, but also their translation into assembly. So 20DDFB is JSR FBDD, and then 60 is RTS. At this point, we can run it with 300G. The reason we can run it is because it's a subroutine and it has a return. So if we call it, it's gonna call it and then it'll return us. So there, let's see what happens. Beep, and it returns. Yay. So we can get out of here. I think last time we figured out we could do it with just type in int. So that's fine. It's easier that way. But Control F2 will get you back here too. And then once we're here, we can call our lower subroutine at 768. And then let's look at this. I'm going to pull up a calculator somewhere. There it is. We're going to change this over from basic to programming. And this is going to give us this sort of view. And we're going to type in, well, we're in decimal mode, so let's just type the decimal number, 768. And we can see right away that it's 300 in base 16. So that's how they map. If we wanted to go the other direction, we can do hexadecimal and 300. And then 768 is base 10. All right, we can also see kind of what the binary looks like. If that's interesting to anybody. But that's kind of interesting. So now we know 768, 300, they're the same thing. So there's the mini assembler. Next up, let's see where we left off. Now we're talking in assembly, right? Into assembler. So I'm going to pull up the source code that we're going to type, and then we'll start Merlin and see what's going on. So the Merlin that we got, that I talked about in the first video, turns out not to be the best one. All right. So better one is 277A Apple Merlin. Okay, this is going to come off of archive.org. That's going to be this one here, Merlin Assembler Disk 277A. This is just it would run it if you wanted to in the little emulator there, but we just want to get it. So we go here to where it says show all. That shows us a bunch of disks and images and all kinds of stuff. But the two that we might be interested in are these two disks. I'm only going to get the first one, and I've gotten it several times, so there it is. Okay, once we download it, we can copy it somewhere useful. So I grab the one I want, I go to where I want it. I'm going to put everything over here, and I paste it in. And then we just have to find it when we want to load it. So I'm going to swap out the disk. Right now we're running in here. I've created in the assembler my code and tested it and stuff like that. But now we want to persist it as an assembly file. So we're going to load up the assembler. So I changed this disk 1 to the Merlin assembler, and I changed the disk 2 to Merlin work. And then I reset. And when it boots this time, it's going to boot into Merlin. Because it's got margins on both sides, you can tell that this is kind of special. Normally it would fill up the whole window and only be 40 characters wide. This is actually running in an 80 character mode, so it's yet another reason to love 277. No, that's not a version number. I have no idea what it is, but it works good, so we're going to use it. Here it is, Merlin, and it's sitting here at this percent prompt, and these are the things you can type. Things we'd be interested in. So we're looking at drive 1 right now, and we might want to do a catalog. So C does catalog. It shows us what is on this disk. So program files, we got Merlin, we got some other stuff, got some utilities, got some sample programs, all kinds of stuff. So that was nice. But we're not particularly interested. Once we get done, and hit space to get through it. But once we're on here, this says other side for more samples. I don't have the other side, I don't think. But anyway, where it says command, we can just press enter. And that brings us back to our main menu. That was drive 1. But we put in a disk over on disk 2, so let's switch over to that disk. And the way we do that is hit D for drive change. All right, and then catalog. We see that there's nothing there but a work file. That's an AppleSoft thing called work. So we press enter to get back to the main menu. And this is where in the Merlin workflow, we want to edit our file. And we know what it's going to look like. It's going to look like this source code right here. But for the time being, and I'm going to try to fit it on, there we go, where I can see both. Move this over a bit. No, I don't Switch, there we go. All right. Yeah, that seems good. So we type E to edit. And it takes us into the editor. The editor is modal. And the commands I can run here are like A for assemble, A for add, I for insert, Q for quit, D for delete, L for list, Q for, yeah, okay, you get the idea. We'll explore it a little together. So I'm going to hit A to add, hit enter. And it's going to take me to line number 1. Now, you see on this, and I'm borrowing heavily from having watched Chris Torrance's stuff several times to learn a little bit about this. But effectively, what we want to do is replicate this source code listing here, because this one works to some degree. All right, so the first thing we want a line of asterisks. We could type them in manually. That's crazy talk. Okay, hit Control and P, and that'll fill up a line with asterisks. Press return to go to the next line, and then he'll, in his video, he'll tell you hit space, Control P, and it'll put a couple of asterisks at the beginning of it. And then we can go tab in a little bit. We can call it ALO3, sample, program, something like that. Press enter, and then Control P to get another line of those. And a couple of lines, well, at least one line. Line 5, yeah, 2 lines. And then line 6, that OBJ 300 thing is kind of important. In later versions of Merlin, not this version, that it's not allowed. But in this version, if you don't do it, things don't work properly. So we're just going to hit space here on line 6, and we're going to type $3, OBJ space, and $300. All right. And then we'll talk a little bit about these in a sec, but then we hit return, go to line 7, hit space. It takes us to the second field, and we're going to type ORG, and then we're going to hit space, and that takes us to the third field, and we're going to type 300 again. The object thing says, the OBJ thing kind of sets where it's going to, where the assembler is going to put it in memory. The ORG thing tells it where, when it is run, from the command prompt, whatever they call that back in the day. But when we get back to the main menu, if we wanted to run it with brun, we type brun, the name of our program, it would know where to load it in memory. So those two things are slightly different, but anyhow, let's move on. So then we type, for this 8th line, we type BELL, which is a label, and that's in our first field. Okay, and so then we go to the second field and we type EQU for equal, and then we take space, takes it to our third field, and we type in an address, FBDD, and then we hit enter. So far we've done commands that use two of the 4 fields, 3 of the 4 fields, and in a minute we're going to do 4 of the 4 fields. So we're going to hit asterisk to insert an empty space after the bell thing. And we're going to create another label called start. We're going to hit space. We're going to jump to subroutine. We've created a label called bell, which really, whatever address bell is at, if we were typing these in byte-wise fashion, that'd be at 300. But in this case, we don't care where it is because we give it a label, and the label is the address. So we jump subroutine bell, and we hit space again, and then we can type semicolon and ring bell. Okay, so we add a comment, and yeah, that's all we need to do. And then I hit return. And believe it or not, that's more than 40 characters, so that would look weird if we were in a 40 character monitor. But because we're in the 80 character, it looks great. All right, and then we're going to type, we're on line 11, we're going to type another label called end, hit space, RTS, which is return for subroutine, and then another space, and a semicolon, and return, and then a return. And then we're going to hit space and CHK, which does a checksum. It's a Merlin command, right? And then we're going to add one here because we can and should. We're going to hit space and we're going to type LST and then a space off. Okay, and all that does is it turns the listing off, which is really annoying. So we're going to turn it off after we compute the checksum. So we're done with it. At this point, we can hit return. It'll insert that little baby slash there. And our code, it looks right. We hope it's right. I'm going to list it. Okay, there it is. It looks right to me. Okay. So if no more changes are needed, we can just go on. But if we needed to make changes, we could do things like um, we could go E for edit 4 maybe, and then go to line 4 and we can type in, this needs work, and it would then edit line 4. And then if we list, we'd see line 4 says this needs work. And I could also go back and do it again with E4. All right, and we can do star, and then I get rid of this stuff. I don't know, spaces and then backspaces, I guess. Who knows? There it is. Yeah, that looks good. And then list it again. All right, so there's that. And we could append by typing 4a, which will append after 4, or 4i, which will insert before 4. Several things like that. But we don't need to make any changes because I typed it right, theoretically, hopefully. But what we can do now is assemble it. And we type asm, and it'll say, do you need to update the source? As though I didn't intend to call asm. We just say no here, and it'll assemble it. And it says so. It says assembling, and then it gives us a listing. And then you'll see that our list looks a lot like what's on the printout. At line 320 DDFB, at line 303, 60, at line 304, 66. That 66 is the checksum. So we know we got the right code. Like if it wasn't 66, I must have typed some of the executable code incorrectly. But in this case, we know it's right. We know it's been assembled. And because we have the OBJ, we know that it's in memory. And so we can do stuff, but we're in the editor right now. And so to get into the monitor, we can type mon, we get the asterisk, and we can do what we normally do, which is 300.304C 20 DD FB 6066, which is exactly what we would expect. Yay. And it means that we can call it. So we can just type 300G, and it should be. And it does, and it returns to us here. And if we want to get out of the monitor, we type Control C, but you don't see any effect. But if you hit enter, then it'll get out of there. Okay. It'd be nice if it went back to the editor, but it doesn't. But that's okay. Just type E, and you're back in the editor. L for list, and you can see your code. If you need to make any changes, this is where you'd make them. When you're done, press Q for quit. It goes back to this thing. Notice that dry 2 is selected. If we do catalog, there's nothing there. We hit enter, it comes back to here. Now we can save source or save our object code. Both exist at this moment. There is source and there is an object. And you can tell that there's an object. I mean, the source is a little confusing. I don't know exactly how to interpret that. But on the object, you can see right there, it says object $A$0300, comma $L$0005, which seems to indicate to me that we have an object that starts at 300 and is 5 bytes long. And when we compiled it, or when we assembled it, that's what we saw in the output. So, and if you don't believe it, go back into your editor, type asm, say no, and you can see it says end assembly. It says it starts at 300 like we expected, and it's 5 bytes. Okay, so we Q, and now we can save source. Just type the letter S. It says save. You get to give it a name. We're going to call it test spell. Press enter. And then if you want to see it, type C for catalog. And there it is, testspell.s. Unfortunately, this is nothing like a text file at all. If you were to look at this in a text editor, it would look really wonky. And it is possible to look at it in a text editor, but there's no point. Going back to here, we can now save the object code. We can hit O. When we do, it already knows the name of it, and it's got this weird syntax. So it says object : test spell, and that question mark, you type Y or no. wire in to agree or disagree. I type Y, it just saves it. We can catalog it, and there it is. When that's the case, we go back to the main menu with enter. And now we're in Merlin, but we can actually get back to like DOS. And the way we get back to DOS is type Q here, and it tells us, and this is important, to get back to Merlin, type ASSEM. Later we'll do that. But we can see we're at the basic prompt. Now this basic prompt is different than the other basic prompt because it's got a solid white square, not a checkbox, checkerboard. It doesn't have a checkerboard. I'm not sure exactly what that entails, but I do notice that it is different. So there you have it. But now we can do things that we could do in DOS. So I can do catalog, shows me disk one. I can do catalog, comma D1 and see what's on disk one. And obviously I can do catalog, comma D2, and that selects this disk. And there we have two files that are meaningful to us. One is this work thing, which is kind of dumb. We don't need it. We could actually get rid of it, but it kind of tells us we're going to work this. But test spell is our binary file, and you can see it says B. And so what we can do is we can B run test spell. And it beeps, and it's nifty, and it's probably in memory. Who knows? Let's try it. Don't cry if it doesn't work. Yeah, it beeps. Okay, call 768 works as well. So to get back to the assembler, what was it? SSEM. Okay, and that gets us back into here. So we've round tripped the whole thing. Let's check the book, see if anything really pops out that we needed to do that we didn't. Yeah, that's all fine. It worked great. Oh, and then we get into another example, which I'll leave for another episode. But basically where we're going to start to move data in and out of memory. But for right now, this is what I wanted to cover in this video. So hope this is useful. Thanks for watching.